Hello everyone, welcome to IMSC 685 MIS. Today's lecture is talking about KNearest Neighbors algorithm for classification. Let's go on with the presentation. Okay, first. And the KNearest Neighbors algorithm is a very simple and very effective algorithm for general classification problem. And um, this is also an algorithm many data scientists or data analytics using as a first attack for their data set. And the famous application including in the financial sectors, and also many of those are in political science using the K-nearest neighbors algorithm for a political campaign, and also some of the advertising industry heavily use this algorithm. Another application is very interesting is so-called handwritten detection, meaning a lot, especially in the U.S. Post Office, you have all the letters and actually coming from the addresses, recipient, and using handwriting, and the camera take a picture of the mail piece and automatically determine what is the destination it needs to go. Um, Therefore, the image recognition is also very uh, popular application for this type of algorithm. And I want to here address two of the main uh, application in financial sector. One is the so-called credit rating. And for example, before you get approved for take out the mortgage or car loan, you need to, and the financial institution will predict the credit rating of a customer, and then using that to determine how risky, if they issue you a loan, how risky it is. And loan disbursement as well, the banking institution will predict whether or not the loan is safe or risky based on the applicant's financial profile. Last point I want to address is this algorithm is, since it's so easy to implement, and it's a very straightforward, and many times for a medium to large database, this is still very effective. We show you later on, um, but the only thing is the comms uh, for this problem, this algorithm is when the data set gets higher dimension in feature, many times and they're not so effective in the end. So we're using other type of algorithm to reconfirm the result from the K-nearest neighbor algorithm. Okay, and this lecture we will focus our application on classification application, and we can give you several examples to talk about in the Python programming portion. Um, So here what we trying to explain the algorithm itself. For example, we just have a imaginary data set between the height and weight for female and male uh, population. So if we plot it out, we're going to get something like this. Okay, and for example, this is a population with height and weight, and and the pink dot represents the female population, and the blue dot represents the male population. So this is our training data set. For example, now we got a new set of data, either in the orange or the green part, and we would like to see the new data and trying to predict their gender is either a male or female. So these are some kind of illustration for you to understand. So basically what we do is, for example, this point, and the far right, the orange point, sorry, the far right, and in the far right, that represents a data point. Clearly, we can classify as a male population because it is very, also this one, probably easier to identify. However, the one close to the dividing line, and this could be very puzzling, which gender they represent. Also, the green line as well in kind of border regions of this data set, and they may get misclassified. For example, the far left of the green dot, and we can clearly easily identify as a female in that sense. Okay, so I'm going to explain the algorithm real quick using a statement. And the algorithm also using a so-called supervised training, training. First, the training algorithm itself is very straightforward. Just store all the data into the training set. And the trick is in the predict algorithm. And actually, for each one of the new data point X, I want to put it into the map and calculate all the distance from this point to all the points in your training data. And we sort the point for your data by distance in an ascending order, and then we predict the majority label of the k closest point, and basically inside a certain range, how many males and population close in my certain range and neighborhood, and how many female population in my neighborhood, and I take the majority of those data points. To illustrate that, let's take a look at an example. For example, the star in the middle, it represents a new data point. If I decide to range, actually, choosing a proximity called your neighborhood, so you calculate how many data points within your neighborhood. For example, if k equals 3, within that neighborhood I have two class B, one class A population. So in this case, I would pick this new point will belongs to class B. Okay, so if I increase the radius, which is increase the size of my neighborhood, therefore I will have a little bit more neighbors basically, and therefore was enlarged the neighborhood, and now I have four actually in class A neighbor and 2 class B neighbor. In this case, the majority should be class A. So this new point will be classified as class A since there's more neighbor in that neighborhood. So the trick of this algorithm really depends on how you choose the size of your neighborhood, and then this is simple counting and basically vote for majority. And this concept itself is straightforward, very easy to calculate. However, if you have many new points, like a test or validation data point, and many huge amount of training data set data point, and this could be less efficient in that sense. So I want to illustrate the effect of the K. So initially you see the pink red region and the blue region. You have data point actually belongs to so k equals to 1, very small. You can do very rigid size of neighborhood is small, you still have these isolated points. When k gets larger, these type of things got included in their neighbor. And if I keep increasing the k, actually some of the point is actually classified else to something else. So the dot color represent the true classification they coming in with, and if they fall into the red region, the pink region, then means they got misclassified into the other class. So when you start keep increasing the value of k, you see less and less people, less and less data point being included into their neighbor in that case. All right. So the question is now, how are we going to determine the best k value uh, in our uh, model? Usually, for classification problem, we refer this kind of approach using a elbow plot, meaning here I have is if I have the misclassification as a measurement, and then I have a variance as a k value, and so we see that initially I have higher value of, if a k is too small, I may have a higher value of misclassification. When I increase k, this issue gradually reduce. And then if I really increase large number of k, and that misclassification also has increased. So we're trying to choose the minima point on this elbow shape as our optimal k value. But however, this particular type of approach require you retrain your data set into every single value of k in order to establish this elbow plot. Fortunately, the k nearest neighbor algorithm is very efficient for medium-sized data set or small-sized data set, and this type of approach may be beneficial. Uh, Okay, so let's quickly summarize the pros and cons for the k-nearest neighbor algorithm. It is very simple, and actually in the training phase you don't do nothing, you just store all the data into your data set and work with any number of classes. It can be binary classification, could be several classes you have. And you can also update create your own training instance over time. So that means today's testing or validation data can be the training data in the future. So your model becomes more and more experienced while you adding more data into the training set. There are only two parameter system training parameter you need to tune. First is the k, of course. This is the distance and how you define what is your neighborhood. And the second parameter is called a distance matrix. Distance matrix is how you calculate the distance from the current point, the new point, to the other points inside your training set. And this can be very creative for different type of application, especially for high dimensional data and what we call the categorical data. Categorical data means you don't have a value, continuous value for that feature. You basically is yes or no category, or is a 1, 2, 3 category, or a certain discrete number of belonging of your category. So since we only have a 2 parameter, so making the tuning of the parameters relatively easy. However, his weakness is many times once you have a large data set, the cost for prediction could be high. Especially you have to compare each one of the new point to all the point in your training data set. This may not be very effective when you have a large data set. And also for the high dimensional data set may not be so effective as well, and meaning you have lots of input variables and dimension and features. Okay. This is usually what we call the curse of dimensionality. And so many times for this type of issues, Usually we suggest you to using subset of your input features and use that to make a preliminary prediction, and you have to have some basic knowledge about your data set and which feature may potentially have more impact on your classification. The last point is about this KNearest neighbor is the categorical feature may not work so well since you have maybe the gender, for example, male, female, or certain type of categorical data, for example, the age group. Instead of like giving you a continuous age data, or you have an age group, so from 10 to 20, 20 to 40, 40 to 60, and these type of categorical data. Or you have many times in a medical application, you have a smoker, non-smoker type of a categorical data. So finally, we coming up to talk about illustrate how the Python implementation we have for this lecture. We're going to give you a work on a so-called breast cancer data set today. Originally, I want to using a hypothetical data set. Later, I decided I want to using a real data set from from the real world. We explain the data set in the notebook for you. And okay, this concludes this part of the lecture. The next lecture, we will start talking about how to implement the KNearest neighbor using a real-world data set.